Disclaimer: this video, examples, images, and references are provided for informational purpose only. The use of the name or mark of any specific manufacturer, commercial product, commodity, or service in this video does not imply endorsement by the U.S. Navy or CNATT. Strict adherence to Naval Aviation Maintenance Program policies and procedures is required while conducting maintenance on aircraft and aeronautical equipment. Some procedures may have been truncated and edited for time. Always consult the applicable governing technical manuals while conducting the maintenance procedure depicted in this video.
Hello, I'm Dan Cheever, call sign Zundra, Air Boss number 10. First of all, thanks for everything you're doing. And today we're talking about corrosion control. The video you're about to see will help you, aviators and aircrew, figure out corrosion control, specifically unscheduled corrosion control, and how you can help us by writing up what you see. When in doubt, if you see corrosion, write it up and let them fix it soon. This will help us maintain our aircraft and extend the life of our aircraft and keep us in warfighting combat readiness. Thank you for everything you do. God bless.
Aircrew Walkaround Flight Inspection.
Hi, I'm Commander Joe Gursky, call sign MANBEARPIG. I'm the safety officer here at VFA 106.
Hello, I'm Lieutenant Dean Corbett, call sign EGGMAN, and I'm an instructor pilot here at VAW 120.
Hello, my name is Lieutenant Commander Dicken Counts, HSE-2, and I'm an aircrew training officer. This video will point out some common areas that you will most likely encounter corrosion while performing a pre-flight, post-flight, or pilot weekly inspection and the proper procedures required to document the corrosion when found.
Early identification and treatment are crucial components in the corrosion prevention and control process to prevent further damage and the necessity for structural repairs. Naval aircraft are continuously subjected to corrosive environments, such as rain, salt water, humidity, dust, direct sunlight, and aircraft fluids, which can lead to extensive corrosion, dry rot, and possible equipment failure. First, we'll start off at AS Oceana. We'll start our review of the corrosion inspection process with the FA-18. Starting at the nose landing gear, we are looking for corrosion and exposed metal that can lead to corrosion. It is important to look at all wire clamps and clamp sheathing for damage. Damaged or missing sheathing can cause friction and contact of dissimilar metals, contributing to corrosion. The inspection criteria for the main landing gear is similar to that of the nose landing gear. The intake is made up of dissimilar metals and other materials that can contribute to corrosion. A combination of aluminum substructure covered with composite skin, fastened with stainless steel fasteners, creates a corrosion cell. A top coat is applied to prevent electrolytes from contacting the dissimilar materials, but cracks, chips, and imperfections in the coatings can lead to corrosion if they are not quickly corrected. Lollipop links are on all aircraft TMS and are highly susceptible to corrosion because the bearings function best when not painted. Connecting links are utilized for several different systems on aircraft. Antenna areas can be a major contributor to corrosion if not properly sealed. Improper application of sealant or lack of sealant on the antenna mount mold line junctions leads to water and contaminant intrusion to the substructure, contributing to corrosion and costly airframe repairs. The last area we will discuss is the windscreen canopy area. Corroded windscreens can lead to discrepancies that require costly depot-level maintenance to repair, if not documented and corrected immediately. Now let's head over to NAS Norfolk Flight Line for additional information on E2D and H-60 aircraft corrosion-prone areas.
Aircraft landing gear systems are constructed of varying materials, such as high-strength steel alloys, aluminum alloys, and cadmium plating with attaching steel fasteners and hardware. Cadmium-plated attaching hardware will start to lose its golden appearance if it is corroded and will appear dull, dark, or rusted. Landing gear struts and peripheral components are susceptible to chipped paint and exposed metal caused by small rock strikes. The degraded coating on these critical parts can lead to corrosion that may be difficult to detect and may lead to premature failure. One area we will inspect is the E2D center wing. This large area has multiple access panels that are prone to chipped paint, exposed metal, and galvanic corrosion around the fastener heads. We also want to inspect for proper sealant integrity around the panels to minimize moisture intrusion into the center wing structure. This inspection methodology also applies to the horizontal and vertical stabilizers. Engine nacelles are subjected to constant debris strikes as well as self-inflicted damage from the use of hand tools and ladders.
Naval aircraft that conduct low-level missions over salt water are exposed to extensive saltwater intrusion that can lead to very expensive corrosion repairs if not detected and corrected in a timely manner. On the exterior, we will look for corroded fasteners around the pilot and co-pilot windscreens, windows, windshield wiper assemblies, and inspect for sealant integrity. A common and costly corroded area in the nose E-bay is the mating surface of the nose door. Pay close attention to the seal in this area. Door mating surfaces are significant corrosion-prone areas. Inside the cockpit, we will look at the deck fasteners, window anchor nuts, restraint buckle assemblies, and the overall condition of the center console.
Upon completion of walkaround flight inspection, it is important and essential to document all the discrepancies found. When creating a work order for the discrepancies found, it is important to use the proper codes. The first code to note is the When Discovered code. The main codes used for post-flight are A. Before flight, abort. B. Before flight, no abort. D. In flight, no abort. E. After flight, between flight. F. Pilot NFO inspection. The next code that is important for documenting post-flight corrosion is Type Work Order codes.
Type Work Order Code DF should be selected when maintenance discrepancies are discovered during pre-flight or post-flight inspections.
The last code we will discuss for aircrew use for documenting corrosion is Type Maintenance Code. B. Unscheduled maintenance. It is important to write work order discrepancies in a manner that the maintenance team can clearly understand and easily find in order to treat the specific corroded area. Pilots, NFOs, and aircrew serve an important role in the overall success of a squadron's corrosion prevention and control program. Your squadron training officer will provide further guidance for corrosion-prone areas on your specific type, model, series aircraft. In closing,
Frequent corrosion inspections are essential to the overall corrosion control program. The cost resulting from corrosion can be minimized by early detection, identification, and treatment.
And now, CNATT MicroLearning, taking the training to the next level.